Let us switch over to problem number 11. Let me read it out first. An object is placed 21 centimeter in front of a concave mirror of radius of curvature 10 centimeter. It's a concave mirror he is giving. Radius of curvature 10 centimeter, that means focal length is going to be 5 centimeter. A glass slab of thickness 3 centimeter and refractive index 1.5 is then placed close to the mirror in the space between the object and the mirror. The portion of final image formed will be, in fact, the position where it is going to be formed we just want. The position of the final image which is formed. That's what actually we want. 4 options are given again. Minus 3.94 centimeter the first option, plus 4.3 centimeter the second option, minus 4.93 the third option, and plus 3.94 centimeter the fourth option. So let us first of all think of a concave mirror is taken and we are placing a glass slab in between the object and the mirror. Obviously, when we place a glass slab, the path that is traced by that light ray increases slightly. What is going to be the increased path? Let us first of all take up. So you can understand well, due to the glass slab, that is increased path, what will be that value? We all know a small formula for this, mu minus 1 times the thickness of the glass slab. Mu refers to the refractive index of the material of the slab, that is of glass, and T is the thickness of that particular slab which is used over there. So you can now write this one, mu being 1.5 minus 1 into 3. This now becomes 1.5 centimeter. So the increased path due to the placement of that glass slab, we have calculated and we have got that one as 1.5 centimeter. Fine. But officially, according to the problem, object is already placed at 21 centimeter. So what will now be the present distance? The present distance to the object. Present distance to the object. What will that value now be? It is 21 plus 1.5. So 22.5 centimeter. That is the present distance to that object what we people are finding. That in the sense what? The moment we place a glass slab, object distance varies. By how much it is varying? You identify by using this formula, it's 1.5 centimeter. And of course, what is the increased length or path? That is 1.5. Then what will be the present distance to that object now? It is 21 plus this value, 22.5 centimeter. In addition to that, he has already provided us focal length is 5 centimeter. Because radius of curvature is given 10 centimeter. Therefore, you can write focal length as r by 2, which now becomes 5 centimeter as such. So this is the present data. And what is it he wants us to calculate? The position of final image formed. Position of final image formed means where the final image is formed, at what distance the final image is being formed here. That is what we want. So we want, and we know this is a concave mirror he is talking. So we certainly know what is mirror formula. 1 by u plus 1 by v is 1 by f. But anyhow we know v definitely will be negative. U also is negative, F also is negative in this case. So let us write the values according to the sign convention. It's 1 over 22.5 with a negative sign plus 1 by V is equal to minus 1 over 5. So you can understand u is negative, f is negative. Automatically, whatever the value of v we are going to get here will also be negative. That is actually the sign convention what we all know as far as concave mirror that is concerned. Now if I simplify this one, 1 by v is equal to 1 by 22.5 minus 1 by 5. Then of course you can rewrite the same thing this way, 5 minus 22.5 divided by 5 times 22.5. Now what is it we just want? We want the value of v, which now can be written as 5 times 22.5 divide 22.5 minus 5. It's just going to be 17.5. That too with a negative sign, 17.5. Okay, you can cut these points here. Here 7 times 25, here 9 times 25. If you simplify this one, 6.43 centimeter with a negative sign you will be getting. Exact value whatever you are going to get as far as the image position that is concerned is minus 6.43 centimeter. That minus sign of course gives you that the distance we are measuring to that image is against the direction of the incident ray. According to the convention, along the direction of the incident ray, one should consider the distance as positive. Against the direction of the incident ray, that distance is to be considered with a negative sign. That's over. Fine. But what is the actual position? This is the position with respect to the slab. But what is the geometrical position we just want? What will now be the geometrical position? Geometrical position when you just take up, this is minus 6.43 and 1.5 centimeter already is there. When object distance increases, image distance decreases over there. So what we should write now? This now can be taken 6.43, right, minus 1.5, that with a negative sign. That is the concept. So you just have to subtract 1.5 from the value. So 6.43 minus 1.5, what is it you are going to get? Exactly 4.93 centimeter you get. So minus 4.93 centimeter. That is the geometrical position of that final image which is being formed by this concave mirror. Already I just have given you the 4 options mentioned there. So which option is directly tallying with this answer what we have got after the calculation? It's the third option which has been given exactly with a negative sign 4.93 centimeter. So you can directly say now this answer for this particular problem is going to be C, the third option which is correct. So just to look at once again in brief, the moment you are placing a glass slab, first and foremost object distance, that path is going to be increased. When object's path is increased, then image distance will be decreased. That is the concept we need to understand. So add 1.5 to that and decide object distance. After getting object distance and focal length, finalize the value of V, which is the image distance from the pole of the mirror. But here, from this V, you have to subtract 1.5 centimeter because image comes closer. By what distance? Once again, the same value of 1.5 centimeter. So officially, you will be getting this one with 4.93 centimeter with a negative sign. The correct option for this one is simply the third option. This is problem number 11 for us. See the problem number 12. A vehicle has a driving mirror of focal length 30 centimeter. First and foremost, one should understand what is this driving mirror. Is it a convex mirror or a concave mirror? When we discuss about the applications or uses of different curved mirrors or spherical mirrors, driving mirror must be a convex mirror. We know very well that has to cover a larger area over there. That is the concept. So it is a convex mirror. Indirectly he is giving us. Fine. Another vehicle of dimensions 2 by 4 by 1.75 meter cube. That of course volume dimensions here he is giving. One is length, one is breadth, one is height like. That is 9 meter away from the mirror of the first vehicle. The second vehicle is now at a distance of 9 meter from the first vehicle, that in the sense the mirror inside the first vehicle. Position of the second vehicle as seen in the mirror of the first vehicle is nearly how much? When we are looking the second vehicle through this mirror, at what distance it appears from this mirror is the question. The options are given this way. First option 30 centimeter, second option 60 centimeter, and third option 90 centimeter, and fourth option 9 meter. That is what actually has been given. If you just look at, sometimes in many number of problems, some unnecessary values are going to be given. In this particular problem also, what is the need for us to know the dimensions of the car? What is the length of that car? What is the breadth of the car? What is the color of the car? What is the thickness of the car? All these things are not necessary at all. But he has given us the dimensions. Though the dimensions will need not be taken into consideration. So first thing we need to understand is, in few problems, when unnecessary data has been provided to us, we should not be tempted towards the data to take or to insert those values in the known formulae what are there for us. When it is not necessary, without any special considerations, you simply leave that data once for all. Now in this case, you need to have only 2 points in memory. One, the focal length of the mirror given is 30 centimeter, first value. What we want is that. And what is the second one he is giving? Second one he is talking about the distance to that particular vehicle number 2 is 9 meter from the mirror in the first. That is going to be object distance and focal length is 30 centimeter given. So let us write the data. So object distance is now 9 meter, of which I can write 900 centimeter. And of course we know the focal length of that particular mirror in the first vehicle is very clearly mentioned as 30 centimeter. And mind, this mirror is convex mirror by nature. So what is the formula we have to apply? 1 by minus u plus 1 by v is equal to 1 by f. In fact, every one of us, we are aware of this point. Excepting object distance, all other distances are to be taken positive by convention as far as convex mirror that is concerned. So we now can rewrite the same this way: minus 1 by 900 plus 1 by v is equal to 1 by f. That f of course is given 1 by 30 here. F is given 30 centimeter. I can write 1 by f can be written as 1 by 30. Now what is it we want? 1 by v now becomes 1 by 30 plus 1 by 900. Suppose if you take this one 900 LCM, like it is 30 times, this is 1 time. So the final image distance will be 900 by 31 centimeter. Fine. 900 by 31 certainly will be less than 30 a little. Not much of a difference. Had it been 30, you would have got 30 centimeters straight away. Now it is 31. So 29.8 or 9 something like we get. But in the problem, he only is asking you the answer nearly. So nearly how much it will be? It will definitely be 30 centimeter only here. So nearly distance, nearby distance, that is the correct and exact value he don't want. He has not given also in the options. One given 30, one given 60, one given 90, all in centimeter. And fourth option is given 9 meters. So totally 900 centimeters the distance is. So no answer is very close to the other one given. The options are so given 30, 60, 90, there is a wide variation. So nearly whenever he asks, the one which is very close to your calculated value, you can adopt that answer. Now in this case, it is nearly 30 centimeter, which of course tallies with the very first option, that is A for us. So only thing you should understand from this problem is the dimensions of the second car what he is talking about, another vehicle, 2 by 4 by 1.75 meter cube. Those dimensions are of absolutely no use for us. You need not consider them at all. Sometimes I may even give you the brand name of the car also, the color of the car also. All those things need not be considered. That is the only point you should understand. So not in this problem alone, I am talking about. In many number of problems, unnecessary data is going to be provided to us just to tempt us. We should not be tempted while taking up that data there. That's important. So the correct answer for this problem number 12 is 30 centimeter. The option is first option, that is A. Check the 13th number. Problem number 13. The sun has a diameter of 8,64,100 miles and is at an average distance of 929 into 10 to the power 5 miles from the earth. It's given 929,00,000. 5 zeros. So 929 into 10 power 5 miles from the earth. A concave mirror of radius 6 meter is used to obtain its image. 6 meter radius. That means radius of curvature is 6 meter. Then automatically you can understand focal length will be half of that radius of curvature, which now becomes 3 meter for us. Fine. What is the question he is asking? The diameter of the image of the solar disk is how much? Whatever the image of the sun we people are going to observe, if you consider that one to be a circular disk, what would be the diameter of that disk he is asking? And the options are given this way: 28 meter the first option, 29 centimeter the second option, 28 millimeter the third option, and 2.8 millimeter the fourth option. Now check once again what exactly we people are going to do for this. The size of the image by size of the object. If I take this, according to the concepts of magnification, it is image distance by object distance. But at the same time, you people should understand in this case, V by U we are talking about. Now, when object is almost at infinite distance, we are talking of sun. Even though he is mentioning the average distance is so much and all, for us such a huge number can be taken as infinity. It is infinite like. Then where will the image be formed? When object is at a very larger distance, the image is going to be formed very close to the focus, or nearby focus, or right at the focus also. So what we should understand? The final image distance is nearly equal to the focal length. So what can we write now here? This V can be written as F, because when object distance is very large, the image distance is going to be very close to the focal length of the mirror. Very close to the focal length means at times we take that one is equal to focal length only. So V by U now can be written as F by U for us. Now what we just want is size of the image. So I must be F by U times O. What are the values he has given? You see there. Focal length, radius of curvature is given 6 meter. So focal length can be taken as 3 meter. What is the average distance to that object he is talking about? 929 into 10 to the power 5 miles. So write the same thing, 929 into 10 to the power 5. Right, whole multiplied by what is the size of that object? Size of the object means in this particular case it is the diameter of the sun. What is the value of diameter of the sun given in the beginning? 864100. So you write the same thing as it is, 8641 into 10 square. Let me write it like this. So if you just simplify this, this goes 10 cube times. So what ultimately you are going to get? 3 into 8641 divided by 929 into 10 cube. If you simplify this one, you will be getting nearby value I am talking about, 28 millimeters you will get. So its value will be 28 mm. 28 millimeter is going to be the diameter of the disk of the sun, what is obtained by means of this concave mirror as the image. Circular disk's diameter he is asking. So what is that value around? It is around 28 millimeter. As I have read earlier, this 28 millimeter is the third option provided for us in the problem. So we can directly write answer for this one as C. Only thing you should get from your past what we have read earlier, magnification. Linear magnification what we are talking about. Linear magnification is size of the image by size of the object. Size while taking up, mind it, maybe the length, maybe the diameter or the radius. Here he is asking diameter. Therefore, diameter of the image by diameter of the object is equal to focal length of the mirror by object distance. Why are we taking V and F equal? That also you can easily identify. When object is at a larger distance, then automatically image distance will be very close to the focal length of the mirror. Therefore, V can be written as F. So this is the way we just have to follow. Rather, to get the result, we have to follow this methodology for this problem number 13. So this is problem 13 for us. Let us switch over to problem number 14. The image of an object placed on the principal axis of a concave mirror of focal length 12 cm is formed at a point which is 10 cm more distant from the mirror than the object. That is the relation what he is mentioning. The image is formed at a point which is 10 centimeter more distant from the mirror than the object. The magnification of the image is how much? The options are given this way: 8/3 the first option, 2.5 the second, 2 the third, and -1.5 the fourth option. According to the given data, focal length is given 12 centimeter. And what is the relation he is giving us? Look at the image formed at a point which is 10 centimeter more distant from the mirror than the object. Suppose if I consider object distance as x, then the image distance should be x plus 10. If I write this one in centimeter, this also can be taken in centimeter. Then what is this mirror formula we have? 1 by f is equal to 1 by u plus 1 by v. But for a concave mirror, u negative, v will be taken negative, f also will be taken negative. Then automatically this now becomes 1 by u plus 1 by v is equal to 1 by f. Just substitute the given values. 1 by 12 is equal to 1 by x plus 1 by x plus 10. Now come on, just simplify this. X into x plus 10 here, x plus 10 plus x, that is 10 plus 2x. Now cross multiply this one, you will be getting 120 plus 24x is equal to x square plus 10x. Now bring these two to the other side. You are left with x square minus 24 plus 10 minus 14x minus 120. This is equal to 0. So if you simplify this equation, you can get the factors for x. In fact, you all know 20 times 6 is going to be 120. So straight away I can write the same x square minus 20x plus 6x minus 120, that is 0. So x into x minus 20 plus 6 into x minus 20, that now is 0. So what are the values? X may be either 6 centimeter or 20 centimeter. Now you have to decide whether this is to be considered for you or this is to be considered for you. He is just giving us focal length 12 centimeter. So for getting a real image, never we should find the object distance less than the focal length. When focal length 12 means object distance cannot be less than 12. So what is the other version we can take up? So x is equal to 20 centimeter. That is the right option out of the two. Now you can identify, this implies object distance will now be 20 centimeter and image distance will now be 30 centimeter. Why 30? You can understand. X plus 10 is now the image distance, that is 30 centimeter. Now after knowing these two, what would be the magnification? That is the question. It is V by U. But already I have told you in the beginning itself, real image formation whenever we consider, magnification should be taken with a negative sign according to the convention. So it is now becoming 30 by 20 with a negative sign. How much will now be the value? Minus 1.5. See the four options already which I have read earlier. Fourth option is exactly minus 1.5. So what can we write now? The answer for this one is simply the value of D. That's minus 1.5. So this is the methodology what you just have to follow. Once again, in this particular case, according to the convention, for a concave mirror, focal length will be taken negative, object distance will be taken negative, and even image distance also will be taken with a negative sign. So this is according to the convention what we have to write, and the same equation can now be rewritten this way, and from which I have calculated x and therefrom the values of u and v. Then what is magnification? It is image distance by object distance with a negative sign. So directly you can take the value as minus 1.5, which is the fourth option according to the given options of this problem number 14. Check the next number, that is 15. A short linear object of length b lies along the axis of a concave mirror of focal length f at a distance u from the pole of the mirror. The size of the image is equal to how much? Size of the image he is asking. That of course he has given 4 different options. First option, b into u minus f by f whole to the power half, that is square root of that. Second option is given b into square root of f by u minus f. Third option, b into u minus f by f. And fourth option, b into f by f minus u whole square. That is actually the fourth option given. So first of all, it is a concave mirror he is talking, and for that the mirror formula can be written as 1 by u plus 1 by v is equal to 1 by f. What we have to do in this case is, first let us differentiate this equation. What will you get when you differentiate? Minus du by u square minus dv by v square is equal to 0. Because you can understand well, in any case of a mirror, object distance and image distance both are variables, but focal length remains constant for that mirror in that medium. So for constants there is no differential value, you all know that one well. So what can we write now from this? Minus du by u square is equal to dv by v square. Now you just write the same this way, dv by du. Bring this one this side and v square this side. V square by u square with a negative sign you are getting. Observe carefully what is the dv here. It is the size of the image. What is the du here? It is the size of the object. What is it he is asking us to calculate? What is the value of dv is the question. So what can we write now? From this I can write dv is equal to v by u whole square into du with a negative sign. But you all can directly understand v over u, that is image distance by object distance, is nothing other than the magnification. What is the other formula for magnification in terms of focal length and object distance given in the problem? You can write the same this way, f by f minus u. This also is one more formula for magnification. So v by u now can be written as f by f minus u, but whole square we have, right square, into du. What is the size of the object given? The length of the object is given as b. So into the value of b I can write. Now look at carefully what is it we have got ultimately. F by f minus u whole square into b. Officially with the negative sign we get, because image distance is taken against the direction of incident ray. So automatically it will become negative. But in the options given, he is not mentioning negative sign, means what? He wants only the distance, that's all. So what is the correct option that is tallied with this calculated value? Look at the fourth option, please. B into F by F minus U whole square. Same value we have got in the fourth option that is given. Therefore, we can say that the correct answer for this one as D. Only thing we should do in this case is size of the image we want, size of the object is given, that is a variation in size. That is what actually one has to understand. For that, taking this mirror formula, differentiate that one. After differentiating, calculate dV by du, where from you just can calculate what is the value of dV. Additional formula which we have used in this calculation is V by U, which is linear magnification of the image, can even be written as F by F minus U in terms of focal length and object distance as such. So this is the calculation what we have taken up. So this is problem number 15, for which the correct answer is the fourth option here. Check that next number, that is problem number 16. The image formed by a convex mirror of focal length 20 centimeter is half the size of the object. Then the distance of the object from the mirror is how much? That means he is giving focal length, he has given you magnification, he is asking you what is the distance to the object, that means what is the value of U. First option is given 20 centimeter, second option 10 centimeter, third option given is 30 centimeter, and fourth option is given 60 centimeter. So let us once again work out the same problem. This is based on convex mirror's magnification. Magnification M is equal to F by F minus U. There is a direct formula like this which all of us we know. Out of that, magnification is given as 1 by 2, half of the size of the object, and focal length is given as 20 by 20 minus U. So what will you get here? 20 minus U is equal to 40. So now U becomes minus 20 centimeter. In fact, you all know pretty well in the case of a convex mirror, excepting the object distance, all other distances are to be taken positive. Only object distance will be taken negative. Image distance will be positive, focal length will be positive. So in this particular case, we are getting object distance minus 20 because that negative sign indicates that we are measuring the distance against the direction of the incident ray. But only value when you want, you need not take that direction into consideration. You can directly take it as 20 centimeters. So what is object distance? That's what he is asking. So object distance from the pole of the mirror is now going to be 20 centimeter. So 20 centimeter is the very first option provided to us. Therefore, we can write the answer for this one as A. So this is the formula directly, if you can remember. Magnification in terms of focal length and object distance. If you know that formula, straight away we can work it out. Otherwise, it takes more time for you to arrive at that formula. Therefore, better remember this direct formula to finalize the correct answer for this model. That is problem number 16, for which the option is A, that is 20 centimeter. Check the next number, that is 17. A convex mirror and a concave mirror of radius 10 centimeter each are placed 15 centimeter apart facing each other. What is the concept he is giving you? You just look at first. There is a concave mirror this way. There is a convex mirror this way. This one is given as concave mirror and this one is given as a convex mirror. And the distance of separation between these two is given as 15 centimeter and its focal length is given 10 centimeter, right? Radius of curvature is given as 5 centimeter here, and even here also the focal length is 5 centimeter. This is the description given in the first sentence. Let us continue. An object placed midway between them. So where is the object located now? You definitely can understand if I take this is the position of the object. Where is it located? 7.5 centimeter from the first mirror, 7.5 centimeter from the second mirror as well. Right in the middle, at the midpoint he is talking about, the object is placed. If the reflection first takes place in the concave mirror and then in the convex mirror. So first reflection is on the surface of the concave mirror, and after that the reflection is taking place on the surface of the convex mirror. The position of the final image is where? Where is the position? He is giving us 4 options. On the pole of the convex mirror, that is the first option. On the pole of the concave mirror, that is the second option. At a distance of 10 centimeter from the convex mirror, that is the third option. At a distance of 5 centimeter from the concave mirror, that is the fourth option. So let us finalize which is the correct option for us. Now, for the concave mirror, let us just write what is the data given to us. Focal length is given 5 centimeter. Object distance is given 7.5 centimeter. Now first and foremost, where is the image that is formed? At what distance the image is formed? Come on, calculate that one. What can we write now? 1 by u plus 1 by v is equal to 1 by f. Anyhow, v will be negative after calculation. So I take this one 1 by minus 7.5 plus 1 by v is equal to 1 by minus 5. What will now be the value of 1 by v now? It is 1 by 7.5 minus 1 by 5. I just can take 15 as LCM here. 2 minus 3, it's now going to be minus 1. So, what will now be the image distance? 15 centimeter with a negative sign. Observe very carefully now. Image distance is 15 centimeter. Where from it is 15 centimeter? The image distance is measured from the pole of the concave mirror. From here, the distance to this image is 15. But already you have been given here, distance between the mirrors also is 15. Then where are you finding the image formed over here? The image due to this concave mirror is formed at a distance of 15 centimeter from its pole. That means where will now be the image? The image lies at the pole of the convex mirror. So image distance and distance of separation both are equal. That means the image formed by concave mirror will now be seen exactly at the pole of the second mirror, that is convex mirror. So what must be your option here? You can directly write this way, since v is equal to 15 centimeter is equal to distance between the mirrors. That is the concept we people have to understand. Therefore, image will be formed. Image will be formed where? At the pole. Pole of what? The convex mirror. At the pole of the convex mirror. So look at the options given. The very first option, if you look at, on the pole of the convex mirror, that is the first option only that is tallied with this. So we can go ahead with this. So answer will now be A for this problem. Only thing you should identify from the problem is, where is the first reflection taking place? When two mirrors are like this arranged, where the first reflection that is taking place, he will mention it, and one should understand it very clearly from the problem. So first reflection is taking place on the concave mirror. Then of course it falls on the convex. That is the concept. So the distance to the image and the distance of separation between the mirrors, since both are equal, I should say that the image formed by concave mirror will now be exactly at the pole of that convex mirror. So automatically the image will be formed on the pole of the convex mirror. That is the right option for us, which is the first option. That is of problem number 17 for us. Switch over to the next number, that is problem number 18. A convergent beam of light converges to a point 20 centimeter behind a convex mirror on the principal axis. An inverted image of the same size is formed coincident with the virtual object. Then the focal length of the convex mirror. Only thing one should understand is the second sentence carefully of this. An inverted image of the same size is formed coincident with the virtual object. Object is virtual and image is coinciding with that virtual object there. Then the focal length of the convex mirror. First option is given 20 centimeter. Second option is given 10 centimeter. Third option is 40 centimeter. And fourth option is 30 centimeter. So if you take once again for this convex mirror, 1 by u plus 1 by v is equal to 1 by f. That is the general formula what we used to consider for as a mirror formula. Now he is talking about 20 centimeter behind. Behind the mirror means that exactly is going to be along the direction of the incident light. So we now can write this one 1 by 20 plus 1 by 20, that is going to be 1 by f. Only thing you should identify is that point. Behind the convex mirror, remember that. Behind the convex mirror, when you are imagining an object, that is a virtual object like, you can take it for granted that the distance to that object is taken along the direction of the incident light. So you have to take that value of u with positive sign according to the convention. Otherwise, what is the general convention over here? U becomes negative, v becomes positive, and f also becomes positive in the case of a convex mirror. But here this u also becomes positive. So what will now be the value of f there? It now is going to be 10 centimeter. Very, very simple calculation. But if you are not in a position to identify this sign properly, both will get cancelled and you may be getting f as infinity. But of course, no option has been mentioned as infinity here. But there is a possibility of giving one of the options as infinite also. So one should be careful in identifying this sign convention. So the total value must be 10 centimeter, that is the focal length of the given mirror. So second option is exactly in coincidence with the value what we have got. Therefore, the answer for this one will be the second option. Okay, so concentrate only on u here to decide the correct answer. That is problem number 18 what we have for us. Check the next number, that is problem number 19. A wonderful question, theoretical concept of course is involved there. A concave mirror forms a real image of an object. If the whole arrangement, not a part of that arrangement please, remember, if the whole arrangement is immersed in water, then the image will, that is a question, of course he has given 4 options, the image will disappear, that is the first option. The image shifts towards the mirror, that is the second option. The image shifts away from the mirror, that is the third option. And the fourth option is image will not suffer any change in its position. That is actually the question given. We just have to identify the right option out of the 4 options given to us. Concave mirror he is talking. For example, if I consider this one the concave mirror, this one the ray, that principal axis, this is the focus, this is the center of curvature. Suppose if I consider there is an object placed here, automatically we can say now the image is going to be formed beyond C. That of course is known to all of us. The image will now be formed somewhere here. Therefore, we can say this is a real image, inverted by nature, enlarged by nature, all the important features related to the image we can give to that. Fine. This is one of the cases out of the 6 what we are having as far as concave mirror that is concerned. I am taking this as the pole. This is the focus. This is the center of curvature. Object is now placed in between, somewhere between F and C. Image is formed beyond C. Fine. Every condition is valid there. Now observe carefully what is he doing. If the whole apparatus, as it is the total arrangement, is immersed in water. In fact, you know very well water is a different medium. Comparing to air, water's density is more. It is a denser medium than air, we people used to consider. Fine. Denser medium and rarer medium concept comes into picture only when the ray of light is refracting there. I repeat once again, denser and rarer media and the influence of these types of media will be there on light only when refraction of light that is taking place. But here what is the phenomena we are observing? It is only reflection. So reflection can never be influenced by different other media there. That means when you are directly dipping this one, the entire system or arrangement is immersed in water. Reflection will never be affected. Due to that, what is the correct option now you guess? Come on, guess that one. Which is the correct option? It is certainly the 4th option, D. It will not suffer any change in position. So what we can understand? When immersed in water, reflection will never be affected. That is the point. So reflection is not going to be affected by this. So what is the correct option? The image will not suffer any change in the position. So it is understood, this implies image will never have any change. That is the concept we have to understand. But let me repeat once again, had it been refraction of light, surely it will be having its own influence. Whatever we can understand, refraction is just between 2 separate media. Now here what is happening? As it is, the entire system is directly immersed in water. So since there is no refraction that is taking place, reflection will never have any sort of an influence on this one. That in the sense, reflection will never be influenced by water. Simple. So the correct option for us is going to be the fourth one. I read out once again, the image will not suffer any change in its position. That is the point. So correct answer for this one is now going to be D. That is problem number 19 what we people are having here.